Now that we've covered kinetic energy, now we're ready to move on to potential energy. And potential energy means it has the potential to release energy, but right now the energy isn't really obvious. So what do we mean by that? Energy is normally pretty obvious, right? It's stuff that's flying fast, or stuff that's on fire, or glowing really bright like an electrical spark, something like that, right? Well, not really. Let's take the example of a mountain. Let's say we have a nice little mountain, and in one of its valleys is a lake. We might say, well, there's not much energy in this picture, is there? Everything's really still and calm. But let's say we dug a tunnel from the lake down to the valley floor. If the water flows through that, it'll come out going really fast. So where's that energy coming from? Energy can't be created or destroyed. That's a commonly known fact, although that wasn't always the case. People didn't used to know that. But we know that now. So the energy has to come somewhere. And in this case, it's stored because the water's been lifted upwards. And this is actually one of the simplest equations for all of energy. And this equation says potential energy equals mgh. The mass is m, g is gravity, and h is how far you've lifted it. That means if you take a 10 kilogram ball, some sort of big weight, and lift it 2 meters, and the acceleration of gravity is 10 meters per second squared downward, then we're talking 200 joules of energy. It's that simple. If it's twice as big, the energy will be twice as large. If it's twice as high up, the energy will be twice as large. If we do another planet where gravity is only 1/2 of what it is here, then the energy is only half as much. And so this equation, PE equals mgh, is paired with kinetic energy equation, 1/2 mv squared. And these two equations together make up the basis of conservation of energy. And the basic idea of conservation of energy is you can transfer from one to the other and vice versa. Like in our mountain example. We had a mountain and there's a lake. And when we dug the tunnel out of the lake, the water flowed out, and before it had potential energy, and now it's lower down, so it's lost potential energy because it's lost height. But now it's going fast because it's picked up kinetic energy. It's picked up speed. And this is true for any kind of potential kinetic energy. If you drop a ball down a skateboard ramp, the ball starts with a lot of potential energy up at the top, and as it rolls, it gets to the bottom, and now it's at the bottom with a lot of kinetic energy. And that's something that's very useful to note, is the potential energy equation can be used either way. Either it can be used to talk about energy added, in which case height is positive. So for instance, if we raise this ball back up the hill, and it has to go 5 meters up the hill, then h equals 5 meters, and then the mass, let's say it's 1 kilogram, times 5 meters, times 10 meters per second squared, that's going to come out as positive. But now let's say we do the opposite. We let it down the hill. Now height is negative 5 meters, and since height is negative 5 meters, it's a negative 5 meters times 1 kilogram times 10 meters per second squared, and that's going to be negative 50 joules. So in this case, it's a negative value because it went down the hill. And this is because we define the positive direction as the direction opposing gravity. Now, why is that? Because that's the direction it takes to add energy. You've noticed this if you ever had to carry something up and down stairs. It's relatively easy to carry it down the stairs. Gravity does the work for you. But carrying it up the stairs, you have to do work. And you're actually doing work in a scientific concept. Because you're applying of some force, carrying it up, across some distance, upwards, which means you did some work. And this work, where'd it go? Well, now we know. It went into creating potential energy. And when you carry it down the stairs, you might feel it speeding you up as you go down the stairs. And that's it's releasing the potential energy into kinetic energy. So try this out a little bit, go over some of the practice problems, and then you're ready to do some calculations converting one to the other.